So let's look at that same workflow in a demonstration, and we're going to do exactly the same thing. We're going to use the software to define a target first of all, and then use a SketchUp model to define this concept study for system-based estimate. And then we're going to use some quantity ratios in an area of the building that we know is similar to a building that we've mined, or at least 3 buildings that we've mined previous quantities from. And then we will show replacing elements from that building with replacing the massing study information with the model elements that are coming from the design team. So let's have a look at, let me switch to Vico Office, and let's start on the software side. The first thing just to note, Vico Office, I don't know, hopefully everyone on the line has had some form of exposure. If you haven't, then the basic introduction is that it's an extremely clean and simple user interface. There are 3 main parts: the workflow panel down the left-hand side, which shows us the areas of interest for our discipline. So if I change the workflow panel to the cost planner workflow, it would change the steps that I would be interested in, so takeoff, cost planning, reporting. In the center is the main view, or view sets, and I have defined for this demonstration some tabs along the top. We can define different configurations of these windows so that we can see different things. I'll show you about that. But the steps down this left-hand side, the workflow steps, would open up a view set with different tabs, tabs and different views open so that you can use them. The third part is the ribbon along the top, and the ribbon really does clean up the user interface. It only shows you the buttons that you need for the view that's active at that point in time. So we're in our dashboard at the moment, and I think that the project that we want to see is this one. So we have a target cost project that is set up and open, and I'm going to dock this workflow panel just so that we get some more space, and I'm going to move to the target tab so that we can see, first of all, a view that shows us on the left-hand side a list of what we call the takeoff items in our takeoff list and takeoff manager. And on the right-hand side, we have what we call the cost plan, which is much like an Excel table, but plus the power of a database, being able to reference information from other projects and reference information from this consolidated list of quantities. And really worthwhile to note as well, this list of quantities, it consolidates quantities from manual inputs that we'll show in this target phase. It can have Excel imported quantities and consolidate also many different BIM applications, the models, quantities in the same list. And we then use those quantities in what we call the source quantity over here. And the source quantity cell has a formula which will enable us to reference the quantities from this takeoff list and use them in a combination of very simple formulas or very detailed formulas depending on your requirements, mathematical, logical, so you can and an or and not and if statements, etc. And that will then evaluate whichever quantities it's pulling and place it into the source quantity, and we can then use waste and consumption factors to translate that quantity into usable and understand the unit of measure. In this example, at the target level, at the target phase, we're going to use some key figures in this takeoff item for defining our square foot for the project. And in order to do that, I'm just going to enter in, for example, if we had 350 workers and we had 40 managers and 15 VPs, just one CEO, copy rooms, if we had 10 copy rooms and 20 meeting rooms, and as you can see, as I'm adding this, it's now adding to this source quantity up in this cell here. So for the toilets, maybe I need maybe 30 toilets, for example. And as I'm defining these, I can also have some foundation factors and skin factors and different added as many different key figures as I would like. And as I'm defining them, we have built up our building square foot of 71,110 square feet. And that's the requirement from the owner for the metrics that we have added so far. We will combine a unit cost based on our historical information, and as a contractor we know that this type of finish and this type of building is going to be $137.50 for the shell and core, which is what we'll estimate, and that equates to $9.7 million. So that's the first level, and it's as easy as that, having a list of key figures, referencing those key figures in order to combine and calculate the required square footage, multiply that by the unit cost, and go to our total price. We'll now move on to use a 3D model, and in order to do that we'll show you SketchUp. And SketchUp is a very simple tool, very easy to use, and if I just rotate around this building type that I've already got, you can see some simple blocks, simple massing blocks. If I was to show you how we came to that, it's essentially creating ourselves some program areas and then pulling and pushing these to assimilate our space and being able to add, for example, another wing to this building. And then the key concept here is just creating them on layers that make sense, and also potentially grouping them or creating components so that the naming convention that is used inside of SketchUp gives us the detailed naming convention in our takeoff list when we use the elements to generate quantities. And that model is then used in, if we go to our 3D Models tab, we can see that we have just gone to import the SketchUp model, and I can simply activate that model, and I can base the takeoff for this version of the model on the group or component or the layer name, or I could combine them both with a hyphen in between them, and that would create our list of the takeoff items for each of the elements, each of the groups or components that we have in the model. When I hit the Activate button, we can see that that same model is displayed in our 3D viewer, and we can rotate around and hit the section box to take cross sections of that and investigate what a powerful modeling capability Clive Jordan has. Actually, no, I borrowed this one from Marcel, I must say. So that's the SketchUp model in, and we can now use these quantities that are generated from each of the elements in our concept level, so developing system-based concept level estimate. And in order to do that, I'm just going to change the view down here and go to the takeoff manager, mini takeoff manager. And I'm going to show that these have already, I've already changed this, but essentially they would be coming in as an object and not being able to calculate any quantities. But we can rebase that and tell it to use the calculation method for a slab for that, because it looks very much like a slab. And when we do that, when we change the calculation rule, it will then start to calculate some very detailed, very useful quantities from that simple element geometry that's come in from SketchUp. So we can start to see things like the top surface area. So in the 3D view, we can see the top surface area. We can use that maybe for, in these, if they were in rooms, they would be for the ceiling finishes, the edge surface area, obviously for cladding finish, and so on and so on. So we can use these quantities to generate the detail in the cost plan at this concept stage. And when I say detail, it is just taking it to a system-based estimate. So as we use those massing model elements, we can then drag previously defined concept level information. So if I choose in my reference browser, I can choose a concept level design that has a uniformat classification system, and I can just drag and drop this uniformat classification system from our reference and bring it into our project. And as I bring it into our project, you'll see that the cells are populated with a more accurate quantity that is being generated by adding up the net surface area, top surface area of each of the floors of the building, and it's being reported and multiplied by a unit cost to give us a new total price. And this is for the substructure broken down into the uniformat classifications, and we can see that we only have, for the foundations level, the floor 1 bottom surface area, which is 20,000 square feet, and multiplied by certain unit rates rolls up to give us a system level cost. Not going into too much detail about the mechanics of Vico Office, but previously our budget was based on $137 per square foot, and that gave us $9.7 million. If I activate the top level to use the lower level components and make it an assembly, what we'll see is that using the lower level, the detail, we can see that the price now changes to $8.4 million, which is a lower cost, and the unit cost is now recalculated to be 119. And if we turn on the variance columns, we can then start to interrogate where those changes are and how much they have been. So by creating more detailed massing model at the moment, based on the numbers in this, we're looking to save over $1 million on this, and it's always nice, a good feel for a demonstration to save money. Hopefully it will end up like that. And the unit cost change has been $18 less. So that's based on the square foot numbers coming from that SketchUp model and more detailed system level square foot pricing and ranges. Once we have used that model to generate this hierarchy of square foot numbers, we can then use our quantity ratios to generate a more detailed, as we saw in the slides, statistical bill of quantities for any elements that are similar in nature to the previous projects that we've used them in. In order to do that, we have an example of a previous project. So here is a project, call this a similar office building, that we know that we've talked with the owner and they are very familiar with this project, and they love the cladding system, they love the exterior enclosure, and they would like something very similar for their project. So in order to do that and use the quantity ratios from this project for our project, we would do a couple of things. The first one, and let's just show you how this is tied together. So for that exterior enclosure, if we click on it, we can see these are the exterior elements, the enclosure elements that are being contributing. These are the walls, and the walls are split into metal panel, brick and block, and here we go, the brick wall, CMU wall, etc. So we can start to see these quantities, and he is very happy with the makeup of this exterior enclosure, and we would like to use those quantity ratios to generate our statistical quantities in our project. So we go to the reporting engine and we create an Excel output of the information in our database. We export that, so we just save this file as an Excel file, and that Excel file, the raw data you can see here, is the export. This is the direct export from that Vico Office file. And what we have here is the quantity and square foot information from that project, for the whole project, for all of those elements in it. I'm going to select and copy that information, and then we have a calculation sheet, which is the gizmo where I will paste the information in. And pasting the information in uses all of the quantity data in order to generate me two new columns, which I'm going to use on the import for our ratio-based reference information. And the new information is calculated based on, here we have an example where we've got the 103,000 square feet from the building. The actual quantity is from this element level 856, and if we divide that through, we can get a ratio which, using the parent quantity, which would be from the system level, so from that concept estimate we just created, we would use the square foot of that building coming from SketchUp multiplied by the ratio to then give us our new quantity. So using these statistical ratios, it gives us a statistical bill of quantities. And in order to do that, so that's the Excel import. So we take the raw data, we copy and paste it to the calculation sheet. We then import it into a project, and we can then use that project as a reference. So when we go to our reference browser for using quantity ratios in this tab, we can go and find that reference and see here, this is the quantity ratios project that I have imported that data into. And then I can look for those elements which I was interested in. So it was the B10, B20. So the B20 category here. So B201, all of these exterior element assemblies. And I'm going to put them into our exterior enclosure here, and I'm going to drag and drop to populate these systems, the exterior walls, the exterior windows, and the exterior doors, with the ratio-based information coming from the project that we've just mined those quantities from. So if I select those, B2001 and down to here, and drag and drop them into the exterior walls, what we'll see is, not instantly because it's not activated yet, so we're still using 1.7 million for the exterior walls, but if we open up that and see how the components now are drawing on the parent assembly quantity, which is the square foot coming from the SketchUp model, multiplied by the ratio that was calculated in that Excel spreadsheet. And based on, so for the exterior metal wall panel, based on that project type, we are rebasing the actual quantity of that metal wall panel, which is the 4,500 calculated square feet, from the ratio that we've mined and the quantity coming from SketchUp. Let's do the same thing for the exterior windows. So the B202 on this side, B202. So we can drag these in, and let's just make sure I've got all of them, put them in the right order. B202, yep, and then B203, I can drag those in. And it will tell me if there's something already in here as well that contains the same code. In this example, I'm going to overwrite it with the more detailed information that we've got from this project, or I could just keep the existing information if I was happy with it. And for these, now the exterior walls, the exterior windows and exterior doors, in order for me to now use these new quantities in and the pricing information in our project, then I'm going to activate the exterior walls assembly, the exterior windows assembly, and the exterior doors assembly. So by selecting them and activating them, we'll now see that the previously 1.7 million has gone to 1.5. Unfortunately, some things do go up, so this one's gone to 75,000. And if we look at those variances in the variance column, we can identify the changes and start to review them with the team. So here we can see that previously we had $1.7 million based on just a system-based information. When we use the ratio-based information using the type of project cladding system that the owner would like that he's selected, it has reduced the cost by $187,000, which is a variance of $2.63 per square foot, the difference between these two. So we can start to develop more and more detail very easily, and we can use this detail in both the estimate and also in the schedule as well. So the next step that we'll go through is using the schedule planner in order to use these quantities and put them into some tasks. So we can use the quantities from the cost plan and resource load, cost load, and quantity load some tasks as well. The simple way to do that, let's use those shell items and sort the list for the exterior and the exterior walls. Let's do that exterior metal panel. So I'll schedule some of these elements for the operation of, let's do the framing and maybe the metal panel as well. So let's do these two activities, the metal stud framing and the metal wall panel. So we can say this is a task, frame exterior walls, and then metal panel to exterior walls. So we put two tasks in order to populate them with the quantities, the costs, and the resources. I just drag and drop the assembly. So the install metal wall panel, I drag and drop into the metal wall panel to exterior wall task. You notice that it disappeared from the list over here. And then I do the same thing for the metal stud framing and put it into the framing. And if you're familiar with Vico Office workflow right now, you'll hopefully be pretty excited about that, because that cuts out a lot of time in the scheduling process, because we can now use the estimating information and the number of drywall hours and the number of sheet metal roofer hours in order to generate our starting point for the schedule. What we are doing is assuming that the estimating hours that have been put in the estimate are correct, but we do have the opportunity to change that from a scheduling point of view and make our own assumptions, or we can ignore the resource level completely and add our own productivity rates in these two columns to calculate the amount of work that we're going to then schedule. And using these tasks now, we can move to divide the building into locations. In this project, I've just kept it pretty simple, and we're going to use floors, so floor by floor. Just turn off that highlighting. We can see floor 2 and isolate, and it is now grabbing just the quantities in this location. So therefore, just the exterior framing and cladding area is going to be generating the amount of time required for the activities in this area. And we can then use those quantities by location in our schedule. And if I open our schedule, we can see, first of all, our familiar, now hopefully on the line, everyone's familiar with Flowline. If you're not, then let's take a look at the Gantt chart, where we can see the two tasks, which have got the framing exterior, and it's got the breakdown of assuming the same amount of framing in each floor at the moment, because we haven't got the model to tell us where it is and where it is not. We're just making assumptions, but we have quantity loaded, we have resource loaded, and we have cost loaded tasks. So we can see the cost for this operation, $7,000 for some framing and $90,000 for the metal panels to go on. And as I mentioned, we can use the resources. Let me just add the resources from the estimator for each of those two tasks. And now you can see that we're going to use a drywaller here and sheet metal roofer to put the metal panels on. And we can start to add some logic between the tasks. So we know that the framing has got to go in before the metal panels. So we say, okay, because of the location structure that we have created in the model, so floor by floor, we're able to leverage that location structure to replicate the logic between each floor and the next floor. And one thing that I didn't mention is the trade logic is automatically defined for us between floors as well. So pretty quickly we can come to a schedule, and we can start to look at what we can do to make that schedule more optimal. In this example, it's pretty simple. We haven't got much detail, but you can imagine using more and more of those ratio-based assemblies can give you more and more of this detail so that you can pull a very detailed schedule from it. And we will then start to align, dragging these lines to tell us that in order to meet this output, we will have to have 2 crews instead of the 1 crew of sheet metal roofers in order to align the production and overall just reduce the amount of unnecessary downtime between those tasks. You can find out a lot more about scheduling and flow line and optimization and also the production controlling in many other webinars and YouTube videos as well. So please search for those. I'm going to leave it there though and go back to see our ratio-based estimate that we have developed. And after, I think we're coming up to the hour, but I will skip over the element-based information just by saying we can source any of our projects. So any project that we have in our database, we can use for referencing that information. So if I have a previous project that has got that type of information in, so if I select, say for example, this Vico office project, I can then use that information to generate true element-based assembly information when I have that model element available. So when the element for the slab on grade is provided to us and the element has been created maybe in a Revit model using a certain naming convention, we can then pull in an assembly from a previous project that either has the same naming convention or a naming convention that we can quickly change, and we will replace the assumptions that we had made, and if we hadn't made any assumptions, we will add directly into this an element based on a true element geometry rather than a ratio-based massing model. And then throughout this whole process, we are very interested in managing that change and understanding how things are moving. So if we, in Cost Explorer mode, we can then identify and see whether we have under or over budget, and even though the shell here is under budget, the contribution of the children is saying that it's less than our original assumption, but the roofing was potentially going to go over budget, as slightly over budget, and it's just because we're making money on the substructure and enclosure that we're still okay in the shell. And we can start to identify and use this tree structure to drill down and see where those costs are changing, see what is over budget, and identify whether it's a problem, be very proactive in managing that change.